I just wasn't sure like what was going on.
Okay, I'm sorry. Might be able to get up. Might be able to get
Try going to the website again. Try opening the new tab and going to the website. Just click right.
Okay, done. Cool.
Thank you.
Okay. Did they really take my microphone? Oh, here we go. So we're going to start off today with the lighter side of signed binary numbers.
Hey guys, Proper English here. I just wanted to record a quick little intro because yesterday I tried to upload this video as one entire part, but it turns out that I can't upload videos that are longer than 15 minutes yet. So I had to take it and split it into two parts, and that's why you're getting it today in two parts. The first part is going to deal with two types of notation called sign magnitude and one's complement, and in the second part you'll see two's complement. All right, so I hope you check both of them out and enjoy. So finally, let's talk about two's complement, which is going to be the most useful out of all the types of negative number notations that we're discussing today. So two's complement actually doesn't have to deal with a negative zero, and it gets a little extra range, and those are the things that make it more useful than the other notations in normal uses, except for some special situations. So let's before we get into those advantages, let's just look at how you convert a positive number to a negative number using two's complement. So we're going to take 1, which is 0, 0, 1, And we're going to convert that to a negative 1, which is 1, 1, 1 in 2's complement. So first, we invert the number. So that's a 0, 0, 1 getting inverted to a 1, 1, 0. We change
That's
the
the ones
zeros to
complement
1s
there.
and the 1s to 0. Then all we do is we add 1 to that. So 1, 1, 0 plus 1 is 1, 1, 1. And yeah, it's that simple. Let's take a look at 2. We'll do a little visual demonstration. So we'll do 0, and we'll call torches a 1 and unpowered redstone 0. So 0, 1, 0, that's 2. So the first step is inversion. So we change that 0 to a 1, this 1 to a 0, and then that 0 to a 1. Then we're going to have to add 1 to this. Well, we've already got a 1 in the 1's place, so we're going to need to carry over. So we end up with 1, 1, 0. And that is our negative 2. Negative 2, 1, 1, 0. The same thing happens with 3. We invert and we add 1. So 0, 1, 1 becomes 1, 0, 0. You add 1 to that, it's 1, 0, 1. That is a negative 3. Now, like I mentioned before, we don't have to deal with a negative 0. So why is that? Well, if we take 0, it's 0, 0, 0. We can invert that to get 1, 1, 1. Then we add 1. And when we add 1, we actually carry across all the bits. And we end up with 1, 0, 0, 0. And what we're going to do is we're going to ignore the 1 in that first position. If we were doing addition and we had 3 bits, we call that 1 the carry out because we don't have a bit for that. So we're just going to ignore it right now and end up with a 0, 0, 0. And we're going to talk more about addition and adders and carry out soon. So you guys can look forward to that. Well, I hope you're looking forward to that. I think it's cool. Now, the other advantage is we get a little more range. We get a negative 4. So we didn't see a negative 4 when we were talking about sign magnitude notation or 1's complement. But in 2's complement, when we have 3 bits, we get a negative 4. And you'll see negative 4 is 1, 0, 0. All right, so you might be wondering, well, isn't 4 1, 0, 0? And that's true. Let's look at the conversion process. We're going to take 1, 0, 0. That's a positive 4. And we're going to convert that into, well, first we'll invert it. 1, or 0, 1, 1. Then we add 1 to that, we get 1, 0, 0. All right? So both with these 3 bits, we see 4 is 1, 0, 0. And negative 4 is 1, 0, 0. Well, how do we deal with that? Well, what we're going to do is we're going to say that 1, 0, 0 is negative 4, and it's not positive 4. In order to get a positive 4, we're going to need to add 1 extra bit, and it'll be 0, 1, 0, 0. And then the conversion, actually, if we can take a look at that. We're going to have a 1 here. All right, so now we're taking 0 to 1, 1 to 0, and then both of these zeros to 1s. Now if we add 1, well, we're going to do the same carrying thing over here, except now we end up with 1, 1, 0, 0. All right, and that is called sign extension. So anytime we're going to take a negative number and we're going to add more bits, okay, what we're going to need to do is we're going to extend this most significant bit over. All right, so let's try that with with a 2. So if you remember from before, for a 2, we're going to invert, and then we're going to add 1, so we get 1, 1, well, 1, 0. 1, 1, 0. Let's fix our graphs there. All right, so if we want to take this and we want to add a fourth bit, well, we're going to add a 1 there. All right, so now 2 would be 1, 1, 1, 0. If we need to add a fifth bit, we're going to add another 1. All right, and these would just be zeros in a positive tail, right? So if we're going to take a positive tail, all right, so 0, 1, 0, and we're going to add an extra bit, well, now we just add one more 0, all right? So if it's a positive number, you're adding more zeros when you add more extra bits. It's a negative 2's complement number, you're adding more 1s when you add extra bits. So I hope all of that made sense. I'm looking at this now, and I've got a bunch of torches and redstone laying around here, and I hope showing this had some meaning for you, and you were able to follow it. Now you understand how to represent positive binary numbers and negative binary numbers. You've got a good foundation for everything else we're going to talk about. We're going to start getting into, next time we're going to start talking about counters, and I'll show you how to build a binary counter. Then we're going to get into logic for addition and subtraction, and maybe even get into some division and multiplication in some more advanced tutorials. So there's a lot to look forward to. I hope you guys are enjoying watching this. If you have any feedback about the tutorials, about things I could do better or explain better, please leave me some messages in the comments, and I'll definitely think about what you guys say, because that's what matters the most, is that you guys are understanding the things that I'm talking about.
There's one more. Oops. I think you might have gotten the 2's complement thing backwards.
Hey guys, Proper English here. I just wanted to record a quick little intro, because yesterday I tried to upload this video as one entire part, but it turns out that I can't upload videos that are longer than 15 minutes yet. So I had to take it and split it into 2 parts, and that's why you're getting it today in 2 parts. The first part is going to deal with 2 types of notation called sign magnitude and 1's complement, and in the second part you'll see 2's complement. All right, so I hope you check both of them out and enjoy.
So finally, let's talk about 2's complement, which is going to be the most useful out of all the types of negative number notations that we're discussing today.
So either he made a mistake or I made a mistake. Which is the most likely? Okay, so we'll stop that point. Okay, so let's start with the sign magnitude. I know we touched on this, but there were some questions when you guys left, and so I just want to make sure we cover all of this. Okay, so you don't have any trouble converting base 10 numbers to base 2 numbers as long as they're positive. We did that the week before. Say 25 equals what in base 2? Let's see, 1, 2, 4. Is that right? Is that right? 65 in base 2 is 1, 2, 4, 8, 16, 31, so forth, okay? But what about when it turns out to be a negative number? So let's do an easy example. Back to negative 25. It's signed magnitude. So the first thing we have to do is just convert 25 to normally, like we would if it was unsigned. So 25 is 1, 0, 0, is that right? So that's 1, okay. No, it's 16 plus 8 plus 1, right? I think I had it right. Isn't that it? Yeah. Okay. So what we have to do is 1, 2, 3, 4, 5, 6, 7 bits, and on our 8th bit we set it to 1. So this is the identical as a positive value, except all we do is we flip that most significant bit, okay? So for assigned magnitude, and I did upload the slides, by the way, just now, so you can take a look at those if you need to. So you start off by converting.
I think we've had
Well, cheap government crap. One, convert the absolute value okay, so an example of that is going to be, say, 67. Let's say negative 67. So the absolute value of negative 67 is 1, let's see, 32, 16, 8, 4. I believe that's right. 1, 2, 3, 4, 5, 6, 7. Okay. So that's positive 67, or the absolute value of 67, right? To make it negative, in signed magnitude, all we do is we set the most significant bit to 1. Otherwise, it would be a 0. Okay, so let's take negative 211. Okay. Oh, see, that doesn't even fit. Sorry. The values that will actually work are all going to be less than 128 for any given number. Otherwise, it will overflow. Okay, so let's take 121. Okay, can you give me the binary? Say, can you give me the binary equivalent of 121? Let's see. That is a 64. That is a 32. 0. Is that right? I'm sure I did that right. You got it? Did I do that?
It says the answer is 1111001.
Is it? Okay. 111.
4 ones. Yeah. 001.
Like that?
Nope, another 0.
Okay. So all we do is we add the sign bit so that it's negative 120. Okay. Let me give you 4 of these to do. So let's do a negative 35. And what I'll need is just give me the bits for the negative number. And negative 35, negative 27, negative 122, negative 109. So you can work this out. Yes, sir. So the largest binary value goes subtract 64. One thing happens to okay, so there's a 32 in there. Okay. There's a 16 in there. There's an 8 in here. And 0, 0, 8. You guys got it? All right. Negative 35 is binary assigned magnitude.
It would be 1000111.
We're missing some bits here though. Add a 1 to the right or left? Like that? Okay, I'm taking your word for it. Negative 27. One, like that. Okay, 122. 122, you got it?
Can you like do it?
Sure.
I can't follow anything.
Sure. Let's do that next one, negative 122. Okay, so the first thing we have to do is convert this to normal binary. So doing it the stick shift way, 64 is there. 8, 5, is that right so far? So we put a 1 in the 64's place. 32 is there, so we put a 1 in the 32's place. Okay, 16 is there, so we put a 1 in the 16's place. 8 is there, so we put a 1 in 8's place.
Can't see this.
Crap. Can you see it now? Okay, there's no 4, but there is a 2, and there's no 1. So that's the binary equivalent, right? And just to make it a negative in the in this system, you just put a 1. Okay? So this is the key to making that a negative. Okay, so if you're good at binary conversion, this is actually pretty easy. All right, let's try 67. Negative 67. Okay, so there is a 64 in there, right? There is no 32, there is no 16, there is no 8, there is no 4, but there is a 2, and there is a 1. And now we need to make it a negative, so we set that most significant bit. One thing I would point out, I'm not sure that I've made this clear. These are all going to be 8-bit numbers that we're going to use. So if we don't have 8 bits for the numbers that we're converting, we need to add them with zeros to the left.
So the first answers that we got are incorrect?
Yeah, I think so.
Because we're putting those in.
All right, let's do this 35. I think we should have padded that, right?
Yeah.
We do have a 32. Okay. We don't have a 16. We don't have an 8. We don't have a 4, but we have a 2 and a 1. So that's 1, 2, 3, 4, 5, 6 bits. There's our padding, and there's our sign bit. Okay, let's do 27.
That's not what you wrote.
Did I do something wrong?
It's different.
I know, because we got the wrong number. We didn't pad this. We didn't pad that either. That's why we're doing these over again. 27. Okay, these are all going to be 8-bit numbers. Yeah. See, notice how I changed the rules in the middle of the game.
Do you have a 64 sign? Not 32? So it has to.
I'm sorry, what now?
You have 64 sign, not 32? Should it be 1001, 0011? Oh, never mind, you're right. 124. Yeah, you're good.
Okay. That's kind of like washing the clothes dryer, you know? You ever wash the clothes dryer? That's kind of what that is.
Yeah.
You know, I brought up beer in my last class, and people really enjoyed that topic. I gotta be careful with you guys, though. I might get myself in a lot of trouble here. Okay, so as far as converting, I think you're all good on this. Now, on Monday, I'm going to give you a study sheet. And on Monday, we're going to probably spend about 15 or 20 minutes going over the study sheet. And Wednesday of next week, you have a little exercise, if you know what I mean. And I'm going to make sure that you all do really well. I like to kind of get you primed for success, so definitely don't get all angry. My CS2 class, they're walking on eggshells now, a week at a time. See, those CS people, they don't enjoy life like you IT people do. Am I allowed to say that?
Yes.
I'm a CS person, but. Yeah. IT people are just more down to earth. And, yes.
Whatever you're done.
I'm done.
Okay. So are we getting? So we're not getting the review this Wednesday. We're getting
Said
it Monday
this
now.
Wednesday.
Yeah, you're going to get it on Monday.
Okay.
Just so I can kind of finish up everything. And Monday I'll cover some new stuff that will not be on the test.
Okay.
Okay. And then that way, you should have time and so forth.
And what do we need to bring to the test? A Scantron or just paper?
Here again, this may be where I changed the rules in the middle of the game.
Good.
I would guess a calculator and a pen probably at this point is what I'm going to tell you to bring. And I'm going to let you use a calculator because some of those numbers just get too big. There's just unreasonable to divide 8,192 by 16 a bunch of times or something. So I'll let you go ahead and use the calculators. So now what we're going to do is add some of these signed. So now we're going to sort of skip the whole. Okay, so now we're going to add, these are, we'll just go ahead and pad them out to 8. So you know they're not going to. So we're going to add these. This is exactly what you would expect in some sort of a. So 1 plus 1, carry, plus 1, carry, plus 1, carry. Oh my goodness. Plus 1, carry, plus 1. So that's our answer. I don't know, what is that number? 1, 2, 4, 8, 16, 32. Okay, so that's really all you do to add these numbers. So that's adding signed. Magnitude. Okay. And what about subtracting? It's about the same thing, really. 0, 0, 1, 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 1, 0, 1, 0. Okay. So 0, we got to borrow, right? Who was asking me about the 2 last week? Who was that asked me about the 2 last Wednesday? Was that person here? Oh, you asked me that too, right? So this is where it comes in, okay? So you're going to borrow a 2 up there, right? So 2 minus 1 is 1.
Where did you do it from?
Yeah, we're doing subtraction. Okay, so we borrowed from this guy has to borrow from this guy. So really, we borrowed here. We borrowed basically straight across. So this is a 1 now, because we borrowed from him, right? This is a 1 because I'm having trouble with my line up here.
Wait, so how did where did you borrow from to get the 2?
I'm having trouble with my line. Let me write this a little neater, okay? Oops. Zero, 0, 1, 0, 1, 1, 0, 0. 1, 1, 0, 1, 2, 3, 4. That's what I had, right? Okay, so let's start right here. So we have to borrow. And when we borrow, we're going to borrow from this place, correct? Mm-hmm. And the value that we're going to borrow is going to essentially be the 2. It's not there, but we're going to borrow down the line, but we have to borrow. And when we borrow, the value will be 2 that we borrow, okay?
So if you have to borrow, it's going to be 2.
Yeah. It's just like when we're doing, it's the same exact thing. Let's say it's 72 minus 38. What you do here is you borrow 10, even though there's no such thing. So we'll say 12 minus 8. Okay. It's the same kind of idea. Okay, so we're going to say 2 minus 1. And we borrowed here, but there was nothing there, right? So we have to borrow from here. So when we borrow from here, it's still a 2, right? But we borrowed 1 for over there, so now it's just a 1. So 1 minus 1 is 0. It's 0 now minus 0. 1 minus, and so forth. I mean, it's the same idea as decimal math.
1 minus 0? What do you mean?
Did I do something wrong?
Yeah, because it's 1, 1 is 0, so then you don't move the 1 over to the left.
Oh, did I?
32 is 9.
Yeah, for the result, you already told us is a 1.
Second 7.3.
What's this?
Yep.
Yeah. Keep going.
This? Oh, oh God, I just totally forgot it. It's 'cause- So just bring that down. Thank you very much. Okay, so let's try another one. And this stuff really is pretty easy, as you can see. It's just kind of tedious. 0, 0, 0, 0, 1, 1, 1, 0. 1, 0, 1, 0. Okay. You have to borrow there. So it's 1. Let me make sure. Okay, so now this is 0. 0, 1. You got to add everything to blank. Okay. Now, I was hoping that video, I didn't watch both of those videos. Was that Second Life he was using? What was he using? Minecraft. I'm really happy, I guess. Everybody Minecraft. But that's a pretty interesting use of Minecraft. I guess. You guys play Minecraft, anybody?
I got lost in the desert, haven't played it since.
What now?
I got lost in the desert, haven't played it since.
I totally get it.
Can't contest the story.
This is a really interesting question. If the Flappy Birds guy could make millions of dollars on Flappy Birds, what does it take to come up with something like Flappy Bird so you can make $1 million?
Something repetitive and mindless.
Repetitive and mindless, that's good. But how would you hit it? How would you make it like click?
Even around twilight.
Okay.
Just a whole bunch of like sound and lights when they do something. Just making like a lab rat. That's exactly what it was. You tap it and you saw like the number increase and then anticipation getting a higher number. You just mimic that. You have yourself $1 million thing like that.
You know what we should do in here? We should do an experiment. I mean, I write apps. We should take the stupidest game possible. That might be like Flappy Bird and just release it. And call it the dumbest game or whatever. I don't know. That'd be really fun, I think.
And then publish it.
Are we splitting profits?
Huh?
Are we splitting profits?
You can have them all. I just want to see what it takes to. I've done a lot of apps, but I've never made any real money on apps. Except when I was doing contract work, then they just pay by the hour, so you don't care. Yeah, it's a great idea. Yeah. No, I think you should do it. Yeah. Okay, so now we're going to talk about one's complement, which he talked about only just a little bit. So here we go. And I'm going to go ahead and stick with my idea of using 8-bit numbers just so that we keep this really consistent. That's a long word. -47. That is what? It's not a 64.
It's 32. And then you have
It is 32.
15 left. So you have
15 was, so it's not a 16. It is an 8. Is that right?
Well, would it be 1? Would it be 1 on the left that's negative?
Yeah. Except we're gonna. That's correct. If it was signed magnitude, it would be. But now we're going to make it a ones complement number. And the ones complement number simply takes a positive number and flips all bits. So, and you notice the most significant bit does turn out to be set. Okay, so that's
You only add the 1 and 2 complement, right?
correct. Correct. We'll do that in a minute. Ones and twos complement. Once you hit the ones complement, twos complement is really easy.
So why don't we add a 1 at the beginning of 47?
Complements one.
Not negative.
This is 1 complement, that's all you add.
I don't get the question.
Because you said it's negative 47, so why didn't you add a 1 at the beginning? To the left of
We're
your...
doing
We're
one
doing
complement.
ones complement now, and for ones complement, all you do is just flip all the bits.
Oh, okay, just work. Okay.
Yeah.
Thank you, sorry.
No, it's okay. I'd rather have you ask me questions. I actually like to ask questions and challenge. It's fun and dandy. Okay, we won't do the conversion of the binary. Okay. Okay, that's 8. So what's the ones complement of this? I mean, this couldn't be much in here, I don't think. Okay. So the ones complement is super easy. So now let's talk about twos complement. So if I take the twos complement of that, we start off with what? We start off with the ones complement first. And then we add 1, right? So in this case, we have no carry. So that's twos complement and ones complement. Yeah, that's pretty easy, right? Everybody grok it? Now we
Why do you have 2 1s at the end? Like, wouldn't you just carry over a single 1? Why do you have 2? Am I not understanding correctly?
Okay, so this was the original number.
Yeah.
And then I flipped all the bits and I got this. And then I added a single 1. I think I did that right.
You did.
I think I just added a single 1.
So you added 0 to 1 to get 1, and then That was all you did. You just had like A1. You didn't go all. Oh, okay, I see what you did.
Yeah. Now I might have had to carry. There are going to be instances where you carry. In that case, you might have to go down the chain. But for right now, it's just adding a single one.
Okay, I see.
Didn't have to carry. Okay. So what we're going to do here is we're going to start off with one's complement. And we are going to add 56 and negative 24. So the first thing we have to do is convert them to one's complement. 56, oh, here it is with these binary conversions. 0, 0, let's see, there is a 32. Was that 24? 24 is easy. Is that enough bits? I believe that's correct. Did I do that right? I need one more bit?
Yeah, one.
Excuse me, Professor.
At the end?
Yeah.
Right there? That's not right. Let me do it. Okay, let me do it the long way. 56 minus 32.
Should be alright, but no.
24, right? So there is a 32, there is a 16, there is an 8, no 4, no 2, no 1. Okay, now I'm missing 2 bits. Okay, now negative 24. I'm going to do my scratch over here. Okay, so negative 24. First thing I do is I convert 24. That's 1, 1, 0, 0, 0. We'll pad it out now. It's 5 bits, 6, 7, 8. So first I find the ones complement. So 1, 1, 0. Crap. 1, 1, 1, 0, 0. You guys won't quote me for saying crap, will you? Okay, so that's the ones complement. So now we go over here. 1, 1, 0, 0, 0. I did some sort of bit miss. Oh, I see what I did. Is that right?
No. You put back that 0.
1, 1, 0, 0, 0, 1.
1, 1,
1,
1,
0,
0,
0,
0,
0.
0,
1, 1.
Yes.
One question,
That's
Professor.
not the same as this.
No. Oh, you were trying to.
That's 24 and the other one.
About 56.
Right, I'm going to add 56 and negative. Yeah. Okay. This is 56, right?
Yes.
Okay. We're going to get a fresh scratch here. That's got the wrong number of 3 zeros. Now, negative 24 was, hopefully I'll get this right, 1, 1, 1, 0, 0, 1, 1, 1. So now all we have to do is add those up. 1, 1.
We can't see.
Oh, small detail. Carry, 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 you have an overflow. Okay, so, and that's one of the things when you're working with these really small 8-bit numbers, you're going to get overflows. So we certainly got an overflow there. This stuff is not rocket science. It just takes a bit of effort to do it. Okay, 2's complement. Let's add 67.
Excuse me?
I didn't understand the carry.
I'm sorry.
Like, what does that mean?
Pardon me?
You just put like a negative in front of it?
Yeah, we actually got an overflow.
I understood that, but so what does that mean?
It means actually our calculations are not good. In programming, what happens when you get an overflow is you experience normally unexpected consequences. You'll get in terms of an overflow, you'll get numbers that you maybe could not have predicted or unexpected. And so that's one of the biggest problems in programming. So basically what you do is you fire the programmer when you get that. And your IT guys, you'd love to fire the programmer probably. So the result of that, since it's an overflow, would be invalid. Yes, sir.
Alright. My question is, for one complement, we flip all the numbers, correct? We flip the ones to 0 and 0 to 1. Alright, so when we made it a binary number, did we flip them for the bottom two that you added?
So this was the ones complement because it was a negative number.
Oh,
Okay.
only because it was negative.
Right.
But
right.
we didn't have
56, it's just normal.
to. Alright.
So we don't have to do anything.
So if it's negative, it would be a 1 complement?
Yeah. And if it's a regular positive number, you don't have to do anything to it.
Alright, thank you.
Okay. 67 plus, what was that?
64, 2, 66, 1.
What number are you going to put here?
You meant like in binary, I'm sorry.
No, I was going to, how about 35? I thought you were volunteering to give me the problem, which would be fine. All right, so let's convert 67. 67, there is a 64 there. After that, no 32. No 16, 8, 4. Is that right? 1, 2, 3, 4, 5, 6, 7. Got to pad up a bit. Negative 35, we start off with just 35, and that's going to be 1 in 32 place. Is that right? Except we have to do the magic on this one, right? And the magic on that one is going to be to make it a ones complement. Okay? So now we're going to add those. 1, 1, 1, 1, 1, 0. Yeah, let's stop. 0, carry it 2. Okay. All right, so now let's move to 2's complement. 2's complement. Here we have, let's go with 67 again, plus negative 124. And that's small enough. Okay, so 67 is 0, 1, 0, 0, 0, 0, 1, 1. Is that right? 1, 2, 3, 4, 5, 6, 7. Negative 124. Well, let's first work out positive 124. So that's 0, 64, 6, 32, 8, 2, 16, 8. That's 12, right? 4, 4, 0, 0. Okay, now, what's the 2's complement of that? Well, first I find the 1's complement. And then I add 1. And in this case, I will get some carries, correct? Okay, so it'll be 0, carry 1, 0, carry 1. Omit this stuff right here. Because that was what we used to just figure out the 2's complement when we add these two numbers. 1, 1, 1. Having trouble transposing these bits here. I have enough bits. 2, 3, 4, 5, 6, 7, 8. And in your book, all right, how many of you actually have this book? Oh, good. Does anybody have a scanner who's got a book? Does anybody have a scanner? Crap. Because I know a lot of you don't have a book. I'd like for you to get some practice out of the book doing this. Okay, 32 through, let's just make it short, 32 through 37. And I don't have a scanner that works at the moment, so that, that's on page 121 and 122. Or you could just do them right now. Would you rather just do them right now? 121 and 122? Why don't we just do them right now? That way you don't have to worry. You don't have to hold it. Let's do problems 32 through 37.
That way you can just do like the odds here and use at home or something like that.
No.
Do the ones not back up here.
Yeah, okay. So just do the odds here and you can do the evens at home. So do those now, please. Page 121. 32 through 37. Let's just do those now for practice.
Can you put the book on the overhead?
Yeah, sure. And when you tell me, I can flip it over. Oh, you can barely read that. Can you read that actually?
Nah.
Oh, that's a lot better. Did those disappear eventually, the little things? I'm thinking they'll eventually disappear.
So the first questions, we're just adding that, what we're doing.
Yes.
Are these answers in the book?
It was supposed that the odds were in the back of the book. They might not be. Can you check? Okay.
Which ones?
I think just the odds are on the back of the book.
You said your notes are up. Are they on the course or on your website? Are they on
Well,
both courses?
They're on web courses. Put the notes on.